Okay, good afternoon. Today we will, in this class, we will try to continue with our discussion with what we had with morning. Uh, just pull up my presentation. Are you all able to see the PPT? Yeah. Are you all able to see the PPT?
Started come.
Yes.
Hasn't come so yet.
Okay.
Came so.
Okay. Right. So these are some of the abbreviations that you all will have to know with regards to your subject point of view. You'll be using tide. Okay. It's actually even called tilde. Then tick, back tick, quote, and which we use or we call it as ampersand. Then caret, sharp for multiplication, parenthesis. Okay, all this we will be using in programming. Okay. Then pipe, then at, colon. Okay, exclamation. So you'll be seeing as to we will be using all these symbols exclusively. Okay, so we will see one by one as to how we are going to do it. After the presentation, I will after the lecture I'll be uploading the presentation onto classroom. Okay, fine. So the combination circuits are always working simultaneously. When do we call a circuit combination? It is called combinational only when it's in combination with few circuits, right? So these are simultaneously working, and it needs to be modeled. Okay, so as I told you in the morning, modeling can be done based on Verilog or VHDL, right? So here you can find your concurrent statements or continuous assignments. So concurrent are statements where which is always ready to be executed, which means anytime it gets executed. But then with the other type of assignment, continuous assignment, it is the other way around. Okay, so which means if you have to use concurrent statements, it is always ready. Okay, which means as soon as you give the concurrent statement, it is ready for execution. There is no time delay. Okay, so this kind of statements we use where we do not we want instantaneous execution of a particular equation. Okay, next, the Verilog simulator continuously monitors the right side of the concurrent statement. So you have the left hand side and the right hand side. So this Verilog simulator will always be checking the right hand side. Okay, so right hand side will have all the equation So here you will have AND operation or operation, right? All these stuffs. So that will be towards your RHS. So that will be always be monitored. And suppose there is any change, okay, uh, towards the right hand side, then immediately it is reevaluated. What do you mean by reevaluated? The equation is again executed, okay, and whatever is the changes, those are incorporated. Now let's take this as an example. You can see the circuit here. You have an AND gate or gate. So AND gate has two inputs, okay, which is A and B. There's one output C. This OR gate has another input called D, and the output for OR gate is E. Now let us use the statements assign. Okay, so in assign statement, okay, what is going to happen is we are using hash 5. Hash 5 here is after 5 units of time. So here it can be normally it is taken in nanoseconds. Okay, so after 5 nanoseconds, this particular equation A and B, logical and B, there are two ands. So this is logical operation of AND is happening, and the value is immediately given to C. C is a variable, right? So similarly here, after another 5 seconds, 5 nanoseconds, whatever is the value of C, so C value is immediately taken here, and that is odd with D. So let us see the explanation here one by one as to how exactly it's happening. Hash 5 indicates a delay of 5 nanoseconds. So normally, as I told you, it will be taken in nanosecond proportion. Okay, and when you have the delay here of each logic gate will have its own delay. So if you have the number of logic gates increased, so the delay also does increase because the delay is being added by each gate. So the more number of gates, the more delay that you will have. So what happens if there is more delay? There will be less. It will take more time for your inputs to occur at the output side. Okay, so that is what you can remember. And then if not included, then the computation will be instantaneous. Suppose this hash 5 is not given, then what is going to happen? Immediately whatever is the value for A and B, that value is taken and given instantaneously to C. But what are we doing here? We are using hash 5, so which means we are purposely adding a delay of 5 nanoseconds. Your variable C gets computed after 5 nanoseconds, and the variable E gets computed after another 5 nanoseconds. So which means 5 plus 5, after 10 nanoseconds we get the output or results at E, because it's waiting for the value of C. C value will be getting after 5 nanoseconds. So after another 5, the value comes and sits here, and this particular equation is computed, and the value of E is taken finally. The order of concurrent statements is not important. So which means I can either keep E at the beginning and then C later, or here we have C at the beginning and E later. So either of the one can be done. Okay, so that's not important. The output for this particular set of equation and the previous one will be the same. Why is it? Because it is assignment statement. We are using equal to, right? So whatever value is there, that is been assigned to the variable C, or whatever value is computed here, that value is assigned to E. Okay. So if you wish to, you can note down this. You can note down the circuit. I'll be sharing this. Now let us see with another circuit as to how exactly it works. Any doubts here you can ask. Any doubts here? You can unmute yourself and ask. Yeah, any doubts here? Aishwarya, any doubts here? Okay, go through it once. If any doubt, you can ask me. Okay, so if there's no doubts, then we will proceed. So here, the thing that you have to understand is the order of the equation doesn't matter. You can either place it on top or at the bottom, anything is fine. It gets executed. Okay, so suppose I put 6 here and then 6 here. So it's going to add up. So after 12 nanoseconds, I'm going to get the final result, which is E. Okay, so that should be kept in mind. Next, we have an AND gate, inverter, OR gate. Okay, and we are now increasing another equation. Previously, we had used two equations, and now we are going to use three equations, and we will see how and exactly it's going to happen. If you see D is equal to A, logical and P. So you have B, A and B is multiplied and given to D. Similarly, E is not of A. Okay, is the negation of A. Similarly, you have F, which is the OR operation of A and C. So this is how you write your statements. This is how your statements are written. So sometimes in your exam, for your exam point of view, I might just give the circuit and I might then write a small code for this using assignment statements. So this is going to be your answer. Okay, fine. So in this example, gate delays have different values. Okay, so here you have 2, you have 1, you have 3. But in the previous one, we had all equal. We had 5 nanoseconds as the common delay, right? So here we have 2, 3, 4, 5, 6. Okay, even though all the statements are getting executed simultaneously, but the instant of time where it appears at the output is different. Okay, if A changes at timestamp 5 nanoseconds, let's take for example. Okay, A is changing. So if A changes at 5 nanoseconds, then B, E, and F, okay, change at 7, 6, and 8 nanoseconds. How is it? For example, at 5 nanoseconds, I'm giving the data. Okay, so 5 plus 2 is how much? 2. So at 2 nanoseconds, I'm going to get the updated value of D. So which means after 2 seconds or 5 seconds. So 5 plus 2 is 8, 7. Then after that, after 1 nanosecond of 5. So which means after 6 nanoseconds, I'm going to get the value of E. Similarly, 5 plus 3, which is 8 nanoseconds, I'm going to get the value of F. Right? So 5 becomes common. So at 5, if I'm giving value of A, and individually again there are delays here, uh, 2 nanoseconds, 1 and 3 nanoseconds, so that adds up to the already having delay of 5 nanoseconds. So ultimately we get the final output at 7, 6 and 8 nanoseconds. So I hope this section is clear, right? So delay is happening here at the input side and delay is happening at the output side as well. Next, so we have something called delay, okay? Delta delay. I might ask you a question, what is delta delay? Delta delay is an infinite small delay which is used to indicate sequentiality between dependent concurrent statements. VHDL simulators display delta delay whereas Verilog simulators do not. Delta is a small delay. Okay, for example, it is taken as a constant. If delta is about 0.5, then this delta becomes a constant and gets multiplied with all. Okay, so it is a very small delay which is used to indicate the sequentiality between dependent concurrent statements. Okay, so if one statement is dependent on the other statement, then there can be a small delay. So that small delay is nothing but called as delta delay. So let's take an expression, for example. One more thing you have to keep in mind is VHDL. This delta delay is related to VHDL, okay, but we do not have this facility in Verilog. In simple words, Verilog does not have delta delay option, but VHDL does have delta delay option. Okay. So this is the general format as to how your delta delay is specified. Assign how much ever delay, name of the signal, okay, signal's name, and then your expression. So if you see your previous, you have assign how much delay, name of the signal, and expression, right? Assign delay signal name is equal to expression. So this is your general format. So which means whenever you have this kind of statement, whenever you have these statements, there are associated delays. So this delays are nothing but delta delays, small delays. And it can be even neglected, this particular delay, right? So that's why it says the delay is optional. So let's take this as an example. The output of clock is actually given to an inverter. So this keeps going on and on. So which means there is a change in clock. Okay, after how much? 10 nanoseconds. So every 10 nanoseconds the values are updated. So you can see from 10 to 20 the value is retained. From 20 to 30 it goes low. From 30 to 40 it's high. 50 to 60 it is again high. 60 to 70 it's going to be low. So the output, okay, if suppose the value is high, here it's going to be low, right? So it it keeps going on, the input and the output keeps going on, but then the updation of signal happens in every 10 nanoseconds. So that is the meaning. So here hash 10 is nothing but your delay. Okay. So here now we will see few examples. What is the statement and what can you expect when you give a statement like that? You have assign #10 where clock is given to the negated clock. So waveform with name clock is produced. What kind of waveform? This waveform is produced. And the name of the waveform becomes CLK. Right. Let us make a small change here. Okay. Assign then CLK. So what is happening here? The name is changed, uppercase to lowercase. So you will again find different waveform getting generated. Now both are different because in Verilog it is case sensitive, lowercase and uppercase. They do not. It doesn't treat them as same. It is different. Right. Okay. So here now we will make another change. CLK is equal to negated CLK. Now here I am not giving any time delay. That is why the waveform will never proceed. So here you can see that giving a delay is actually very much important. Since there is no delay here, what is happening? There is no change and hence the waveform doesn't proceed. Now these can be asked for your exams, these particular statements. These are some rules. Okay. A Verilog identifier or a signal name cannot contain letters. So it cannot just contain only alphabets. Okay, it cannot contain numbers. Okay, but underscore you can use. For example, and underscore gate, that is allowed. Okay, you just cannot use and, or you just cannot use your file name as 3. So numbers cannot be used. Okay, but it can be used with an underscore and with a dollar sign. Dollar sign is actually system reserved. Okay, so letters you can use, numbers you can use, but underscore and dollar sign, these are what reserved. So dollar sign is used for task. Okay, so you can use and underscore gate. You just cannot use only underscore. Your file name cannot start with underscore. A Verilog identifier must start with a letter or an underscore character. So you can use a letter, okay, to start or to name your file. Then a Verilog identifier, you cannot name it with a number or dollar sign. Why is it? Because dollar sign is system reserved. Okay, it is used for system task. So these are some of the rules that you'll have to remember. So identifier can have a signal name, okay, which can have uh, letters, numbers, okay, those can be used for your file name, but then underscore and dollar cannot be used. Dollar is used for system task. Right. So here you have some adder. These are some of the list of valid names. These are the list of invalid names. Okay, it's valid because it's using a character. Okay, here it's invalid because it starts with a number. Here also it's invalid because it's using a dollar. Invalid because this is system reserved, always is keyword, so we cannot use a keyword. Then I cannot use underscore, it cannot start with an underscore, right? Okay, so here it becomes valid Okay, because I'm using something else along with it. Hash I cannot use. Okay, hash I cannot use. Fine. Every Verilog statement must be terminated with a semicolon. Okay, so this is very much important. Semicolon is nothing but like this. Okay, anything following double slash, okay, that becomes your comment. If you use this, it becomes a comment. Comments for more than one line. Suppose your comment is starting from here and ending here. So what do? You have a slash. Okay, you can use a slash star. Okay, and then you can use a star and a slash. So this is going to be your full comment. If it's only single line, then you can use just a double slash. If it's more than one line, then this is the format that you have to use. Okay, next there are some words, keywords such as and, or, always. So these are all reserved keywords, you cannot use them. Okay, like how we have it here, we cannot use them. It's all reserved. Fine. So I think we will stop here, and we will continue in the next class from here. Okay, because this is going to come with wire concepts. This is going to come with base values. Okay, index range. Okay, so let me not confuse you with many concepts today. So we will stop here and we'll continue in the next class. So any doubts you can please ask me if there is anything. Yes, any doubts you can ask me. Hello, Shreyas. Only thing that you will have to know here is the rules, okay, as to how you can use your naming, and here also. So just remember that you cannot use numbers, okay, you cannot use dollar sign, because these are all reserved, and you cannot use keywords. Okay, so that's important. Then remember about delta delay. Delta delay was exclusively used for VHDL, and it doesn't have, or we do not have it in Verilog. Okay, and this is how due to delay the waveform generation happens. Right. So here also we have seen initial delay and then delay because of each statements, how it gets added, and accordingly we get the outputs. Order doesn't matter here. Statement can be either top or bottom. Okay, so concurrent statements are always ready to be executed. So these are some of the key points that you will have to remember for today's class. Okay, so in tomorrow's class we will continue with vectors. Okay. Thank you.